Okay, no problem.
And where we will begin is I'm going to start sharing. And at any time you have questions, please just ask.
Yes, no problem.
Okay, so we are at pulseroller.com, and we will begin by selecting products, convey links. And this is our standard module. It's been around since I've been with the company, and that's over 17 years now. It's gone through a lot of developments, and it's still our stable. Up until the fall of last year, we still had conveyors with 17-year-old modules on them, and they were running our latest and greatest firmware with no issues, still connecting to Siemens and Allen Bradley and everybody else. So the modules are very robust. This page is kind of the the line cards, all the bells and whistles, performance things, and then there's some links here to various different features and accessories. But we'll begin with here the user manual. And so this shows the various versions of the module. This one's the standard one. This module is the HTF high torque freezer. So this is for cold and for freezer environments and heavy duty applications like pallet rollers moving thousands of pounds. And as you can see, simply by looking at the power connectors, the HTF is almost twice as large.
Correct.
It needs to be larger to be able to handle the more current draw. And then for both versions, there's also a black labeled version. And the ones with black label are ETL listed, tested to all the UL specs. Basically means if something happens to the electronics underneath, this cover will not catch fire.
Okay.
Throughout the manual, you're going to see various times where you're going to see the exclamation mark and some red information. This is just something extra about the topic. I do like to discuss this one. It talks about ESD. It's not that the modules are really sensitive. You could pull the cover off, and unless you've been walking on a carpet, you can touch the card. You're not going to destroy it. What we worry about is what builds up in on the conveyor during operation. You're going to have metal, plastic, cardboard, a dry environment. Static is going to build up. If it doesn't have somewhere to go, it can either go into the motor and destroy the Hall effect sensors, which are used for positioning, or it could go through the cable into the card and destroy the motor control circuit. So proper grounding is very important. This right here will solve probably 90% of your communications errors. Basically, your DC, you bring your AC power in for your DC power supply. You tie DC common to that ground. Then when you take your hot and common along your conveyor, you can use that DC common and put a little clamp into it, a little, like a Scotch lock or a vampire clip, and have a wire with an eyelet. Use a tech screw right into the conveyor. Now your conveyor is bonded to the same ground. After that, it's a good thing to take your voltmeter, put on continuity, touch the conveyor and the motor bracket. If you don't have continuity, either loosen it up and scratch off some paint underneath the bracket, or add a ground wire to one of the bolts. That way, anything that builds up on the motor has a path to ground as well.
Correct.
When they're asked, well, what are symptoms? You're going to get, for some reason, a motor short circuit or Hall effect error. Oh, there's nothing wrong with this motor. Why would it break? When you send it back to us and we open it up, if we see that those sensors that detect position are cracked, that's ESD strikes. On the processor, you have a processor, and then you have another little part of the processor called the clock. And a clock is what sets the frequency for the processor to function. If there's an ESD strike on the card, it'll interrupt that clock, and then the processor gets out of sync and doesn't function. Kind of almost requires a power cycle to get it to start functioning again because the clock got out of time. So these are just symptoms of ESD strikes, and then proper grounding will help resolve those issues.
Okay.
There's a lot of terminology in the documentation, as you would expect. Up here in the glossary, you'll probably find things that you're unfamiliar with. Some of this is product specific, industry specific, and then some general terms. On the getting started, who should use this manual? Everybody. I still use this manual. Once we went from PDFs to the online version, it made it a lot easier, excuse me, for us to keep it up to date. So the manual is an excellent source for information.
Okay.
Hardware. So as we're looking at the module, we have the left sensor port and LED, left control port and LED, left motor port and LED, left Ethernet port and LED. And of course, on this side, we have the right Ethernet port and LED, right motor port and LED, right control port and LED, and the right sensor port and LED. I make it a point to left, 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 and right, right, right for a reason.
Okay.
In documentation, software, and electronic files, when you see the words left and right, that means physical left and right as we're looking at this card. If you see the words upstream, downstream, that depends on flow. Example, if we flow left to right, left is upstream, right is downstream. But if we flow right to left, right becomes upstream and left becomes downstream. So physical left, right do not change, but upstream and downstream can, depending on your product flow. Our power connector and LED, module status, LED, network status, LED. Then we have the install button. This button serves three purposes. Number one, you can perform an auto configure with this button. Number two, you can remove everything, every connection, all the sensors, motors, and Ethernet, apply only power, and you can perform a factory default procedure, which would make this card back to all the factory settings. Number three, if a system has been properly auto-configured and a module becomes damaged or somehow unfunctioning, there is an automatic replacement procedure where you take a brand new card, put it in the network, press this button, and then this card will retrieve all of its settings from the neighbor. So it's automatic replacement. It'll get all the settings, including IP addresses and firmware.
From the upstream or downstream card?
That's tricky. When you initiate the procedure, whichever module connects first within those nanoseconds of electronics, the very first one that connects is the one that will supply the firmware. But the other modules will provide information to let us know, can we even perform the auto replace procedure? So it's a combination of two modules to verify, yes, I can do it. But then at those nanoseconds, the module that actually connected first would be the one to provide the firmware on the new card. The exception is if you have to replace your first or last card, because they only have one neighbor, there's only going to be one module to verify and replace information.
Mm-hmm.
With that said, this button, when you're able to use Easy Roll Plus, all three functions can be performed with the software. The button is no longer required with new firmware and new software.
Okay.
These are just mounting dimensions, length, width, depth of the product, and then down here, the mounting tabs. These are the tab locations. This is probably more for a manufacturer. Somebody wants to punch their conveyor or make their own mounting brackets. And we do offer a couple brackets. Only one is shown here. It's called the universal bracket univ, but it's basically an L-shaped bracket. So you can put it in the C channel, outside of the C channel, hang it pointed up or pointed down. And because of all the holes, the module will mount right side up.
Okay.
Motor ports. Here you can see these are 9-pin JST connectors. We call them JST motors for that reason. Pin 1 is ground. Pin 2 is voltage for the Hall effect sensors. They provide feedback through wires 6, 7, and 8, the Hall effect sensors.
Mm-hmm.
3 through 5 are their actual motor windings. So you can see it's a 3-phase brushless DC motor.
Mm-hmm.
And then pin 9, here this motor does not have a wire in pin 9. Pin 9 is for an optional mechanical brake. So this motor does not have the optional brake.
Mm-hmm.
And by brake, it's a holding brake. It's not the calipers on the front of your car to help you stop. It's the handbrake you set once you have stopped to hold you in position.
Okay.
That's how our brake works. Usually only recommended for incline and decline applications. Oh, I should mention, it's not listed I don't think it's listed in our documentation, but if you would like, I can provide you with the connector part number, the little ferrules that go on here, that part number, and the part number for a crimp tool, in case you need to make repairs in the field.
Okay.
Sensor and control ports. Although the sensor port is a 6-pin connector, which means it's an RJ12 because it's 6-pin, we only use 4 wires. So if you wanted to have some spare connectors around to fix broken photo eyes and the whatnot, this connector would be a 6P4C. 6P means 6-pin size. 4C means only 4 conductors. So pins 1 and 6 are filled in with plastic. That makes it real easy for these wires to slide in the center. Pin 2 is ground. Pin 3 is for the sensor error, health, gain, whatever your terminology is. And it is auto detect for NPN or PNP. If the error signal is energized, the LED will be red. Pin 4 is the sensor signal. It is auto detect for NPN, PNP, and when energized, will turn the LED green. Pin 5 is voltage. Just a little warning, if you have to make your own connections, be sure that you have nice clean cuts so you no little stray little wires, because if you're short across either hot or common, you can destroy the sensor circuit inside the car. The control port. Here you can see all 6 pins are used. So if you wanted to redo any connectors for this port, that would be a 6P, 6C, 6-pin, 6 conductors. And we'll start with pin 2, ground. Pin 3, when energized, will turn the LED red. It too is auto detect NPN or PNP. If your module is in ZPA mode and pin 3 is on, that means force accumulate that zone. If your module is in PLC mode, it just means the input is on. What does it? It's up to the programmer to decide what to do with it. Pin 4, when energized on the control port, will turn the LED green. It is auto detect in PN, PNP. When the module is in ZPA mode, pin 4 is for interlocking. Example, node 1, the most upstream zone, you turn on pin 4. That's a wake up signal. Wake up, here comes a load. If it's on the most downstream zone, the most downstream card, and it's energized, that means lane full. Accumulate your zone, downstream is full. In PLC mode, it just means the input is on.
Okay.
Pin 5 is voltage. And for right now, for simplicity, let's think of on the card itself, on the module, pin 1 and pin 6. Both are connected to a dry contact. By default, when the zone photo eye is blocked in ZPA mode, that contact closes. So here would be an example of functionality. You would connect one of our little SE breakout boards to the control port, one of these little things. And it has a cable from here that goes to the control port. One of the wires is voltage. So voltage comes over here on pin 5. On this little board, it's also connected to pin 6, which means it goes back to the card. Now the photo eye becomes blocked and that contact closes. That 24 volts goes to pin 1 and comes back to here. And it's hard to see, but this says out. So this is the output from this card indicating the zone photo eye is blocked. And so this can be used for simple 2-wire handshakes with other people's equipment. It can also be used for whatever you would like. It has pin 4 and pin 3 input signals, and of course the output. So you could use this for interlocking, or I'll show you later, there's a way that you can tell the card, your control port is no longer used for interlocking. It's now 2 spare inputs and a spare output for the PLC to use.
Gotcha.
So that means each card, actually, if the ports aren't used, have 4 spare inputs and 2 spare outputs apiece, readily available. Ethernet ports. Our Ethernet switch is a 3-port switch. It passes data straight through, and the card will only react upon data specifically for the card. Port 1 is the left port. Port 2 is the right port. Port 3 goes up to the processor. And as you can see, this is a caged switch. So that's why we definitely recommend shielded Ethernet cables. This too helps against static buildup, ESD buildup along the conveyor. If you was to take your voltmeter, put it on continuity, touch the cage, and then the DC common on the power connector, you won't see continuity. But when you switch it to resistance, it's right at 2 mega ohms. So it is all tied internally. The circuitry connects the cage and DC common. That way there's a path to ground for any static that builds up.
Okay.
This little note here about hardware 1, these cards are from 17 years ago. Unless you come here and look at an old relic, you'll never see a hardware 1 card in the field. The easiest way to recognize a hardware 1 card is the release tab. Here you can see the tab, and it's in the front of the card. hardware one. This tab is down here in the back of the card. So like I said, you'll never see that unless you come here and I show you some old cards.
Okay.
But still, shielded Ethernet cables are definitely suggested. Internal fusing. So from the power connector, we go straight to the motor control circuits, and the current delivery is controlled by the firmware. We then go through a 300 milliamp electronic fuse, which powers the processor. And then each side of the card, the left sensor control ports, has a 100 milliamp fuse, and so does the right side for the sensor and control ports. If you overdraw the current, these electronic fuses will get hot and open up. And when the condition that was drawing the excessive current goes away, they will cool down and reset. Over voltage protection. We try to protect the card in two ways. Number one, from a power supply. Somehow your power supply messes up and it starts putting out, over 30 volts. We have a clamp down chip. Once the voltage reaches 33 volts, it'll start clamping that voltage down to DC common. And it works through, I believe, all the way up through 47, 48 volts. Once you get to that 50 volt range, you're going to blow that chip. But again, it's kind of a small chip, but this is to help protect against somebody else's piece of equipment. Sure, we could make it bigger, but then the card would get bigger and then the price would get bigger as well.
Great.
Overdriven motor. They're DC, although they're DC motors, they're also generators. So if you was to plug a card into a motor without power on it, on the card, and started spinning that motor by hand, that card would power up. That's regen. And what we talk about an overdriven motor is a motor being pushed or driven faster than the commanded speed. Example, let's just say you set the speed for 100%, and an operator takes a 20-pound box and just shoves it down the conveyor. Well, if 100% was 100 feet a minute, and they push that box at 120 feet a minute, well, that would regen electric back into the power bus, back through the motor to the car.
Correct.
When that happens, once we detect 30 volts or larger, we instead of commutating the motor, we switch those motor windings to ground to try to get rid of that over voltage. We're trying to help protect against an external force. LED status indicators. This one's a funny one for me. Although I was here in the early stages, I was not involved with product development at the time. I was a new employee, so I didn't have that privilege.
Gotcha.
And they decided to determine that blinking is approximately half second. Flashing is approximately a quarter second. 17 years ago, I could barely tell the difference. Today, my eyes are a little older, a little more tired. I can't tell the difference, and it's perfectly okay. What I've learned, and we will discuss that in this position, module status, the one LED, could mean all of this.
Right.
And you're expected to determine the difference between a quarter and a half second. I figured out a different way to interpret this LED, and I think it makes sense. So we'll start with the easy ones. Ethernet links, off, no connection. Solid green, there's a connection to another device. Blinking green, we're passing data. Motors, off, no errors, the motor's not running. Solid green, the motor's running. Flashing green intermittently. This would happen if the motor is not being told to run, but something external is rotating it, like somebody pushing it with their hand.
Mm.
Do that, you get feedback from the Hall effect sensors, and that's what will show that green LED. You're externally rotating that motor.
Mm.
Solid red. The motor's not connected or stalled. Well, it's pretty easy to determine, is it connected or not? So if it is connected and you have solid red, that means stalled. Stalled is a condition where the motor is running at less than 10% of the set speed. The motor's struggling. Either it was underpowered from the start, or maybe you have loads wedged in the conveyor, maybe bands and things have worn out. The motor's struggling, and that's the indication. Blinking red. The motor is overloaded or overheated. An overload occurs when the motor has been stalled for 20 seconds. So it's struggling. 20 seconds later, set the overload fault.
Okay.
The overload fault will auto reset after 60 seconds. If you see a blinking red, it could also mean the motor is overheated. The motor temperature is a calculation of current over time, IT squared.
Mm-hmm.
I've been drawing this much current for this amount of time. I'm this hot. If the calculation reaches 105 Celsius, the card will stop running the motor. When a calculation determines the motor has cooled down to 90 Celsius, it will then resume functionality.
Mm-hmm.
So if you walk up on a card, you see blinking red, wait 60 seconds. If it resumes, well, that meant it was an overload. But if it doesn't auto reset after 60 seconds, it means you're experiencing an overheat condition.
Okay.
Flashing red could either mean a short circuit between two phases or an overcurrent condition. So if the motor's running and you see it flashing red and basically intermittently, that's indicating overcurrent. Overcurrent is normal on startup because of inducing current for the acceleration. It might spike over the set amount, which would indicate overcurrent. And on decel, it may have to induce some extra current to help stop the load. That's just normal. But if your zone's, say the zone's just running, and then a load shows up and you see a little bit of flashing red, that's another indication of maybe check the zone. For some reason, this load's drawing a little extra current. It really shouldn't be.
Okay.
So possible mechanical obstruction, worn out parts, etc. Module status LED. This is the one where don't think of, especially these two, don't think about flashing and blinking. Think about what am I doing and what is the module supposed to be doing.
Mm-hmm.
And this will kind of be obvious when we go through these. Solid red. Either the module is booting up, you turned it on, or during auto replacement, you're attempting to get data from another card. So did you just turn on the card or did you initiate auto replace? You would expect a solid red.
Okay.
Blinking red. It's starting up its internal tasks and processes. Example, motor control, communications, sensor inputs, those types of things. Blinking green, the module is ready. And then we have these two here, flashing green, blinking red, or flashing red, blinking green. So flashing green, blinking red means auto replace procedure has been triggered. Did you initiate auto replace? Yes. Well, then you would expect this. Did you initiate auto replace? No. Well, then it's probably going to be fail-safe mode. The only time I have seen fail-safe has been when someone was upgrading firmware
Mm-hmm.
and they lost power. Just like Microsoft says, if you're going to upgrade Your PC from Windows 10 to 11, you better be plugged into the wall. Don't lose power. Same type of thing.
Right.
The good thing is, we can, most of the time, the customer can get the module at a fail-safe by performing the factory default procedure a couple of times.
Mm-hmm.
But if you can't, you call us, let us know. And as long as you'll pay for shipping both ways, you can ship the modules back to us, and we'll pull the covers off, connect up to the processor, get it running again, and ship them right back to you.
Okay.
Flashing red, auto configure is active, so you initiated auto configure. Blinking amber, this is a firmware check, and solid amber is a firmware upgrade or downgrade, whichever the process is in process.
Okay.
The network status LED, solid red, you're starting inter module communications. That's the left and right side of a car, upstream, downstream of one car talking to itself.
Mm-hmm.
Blinking red, establishing inter-module connections. That would be node 2 talking to node 3 and establishing connections to node 1. External inter-module connections.
Gotcha.
Then once it's blinking green, connections are established and you're ready to go. Sensor indicators, solid green, that's pin 4, your sensor signal is on. Solid red, that's pin 3, that's sensor health, gain, error, that one is on. Blinking red is either an arrival jam or a missing sensor. The missing sensor part's pretty easy to determine. It's probably going to be a hanging wire or a broken connector, something like that. But the arrival jam, by default, of course, in ZPA mode, when a zone releases a load, it expects confirmation that load made it somewhere. It's usually the next zone. If it's your last zone, it could be a lane full photo eye.
Mm-hmm.
If you're diverting, or even your last zone, it could be a bit set by the PLC. Example, like the divert confirm. Your PLC would give your system the divert confirm, and at the same time, that divert confirm would be your confirmation the load made it somewhere. Thus, no more arrival jam. Blinking green and amber is a sensor jam. It's green because the sensor's blocked, and amber because the red LED is turning on and off as well. A sensor jam occurs when the zone tries to release, but the sensor never clears.
Mm-hmm.
By default, there's a procedure called sensor jam auto clear. So first thing that happens, the zone tries to release. It can't. So it sets the fault, it waits the reset time, and then the auto clear procedure begins. That is when the zone will rotate reverse to try to clear the sensor, rotate back, and try to release again. It'll do that 3 times.
Mm.
After the 3rd time, if the sensor is still blocked, that zone becomes permanently jammed. And the only way to clear it is to either physically remove the load or press a button in the software that says clear the jam. If it happens, you really should, go take a look at that area. Something is jammed in there. Again, by default, that is on. But for some applications, you may want to turn that off by default. An example would be you have a 24-inch zone, but a 22 or 23-inch product. And if it had to rotate backwards to clear the eye, it might bump another load in the other zone, which point that feature would not be desirable. So you could disable that feature. Lastly, if you walk up on a zone and there's a load blocking the photo eye, and the LED is flashing green, that means something external is forcing accumulation. Example, a PLC is setting the accumulate bit, or someone has opened up Easy Roll and clicked the accumulate button. So flashing green is your indication that something external is forcing accumulation. Control ports, solid green, pin 4 is on. ZPA mode on the most upstream, again, that's wake up. The most downstream, that's lane full.
Mm-hmm.
And PLC mode, it just means pin 4 is on.
Okay, let's go back there, because when we went over it earlier, I had some more questions, but I figured you'd go in a little bit more detail on the control port.
Okay, yeah, go ahead. Yeah,
let's talk control port in ZPA mode.
Okay.
Okay, so what are we talking about in terms when you say solid green in ZPA?
Okay, so ZPA means that's the mode the card's functioning in. ZPA, zero pressure accumulation. The card is using its own internal logic, talking to other cards, and moving a load along the conveyor.
Okay.
The PLC, when a module is in ZPA mode, the PLC would perform interlocking. It could change speeds. It can accumulate, read, write tracking data, simple things.
Mm-hmm.
And that's what part of the control port's for, is for interlocking. So if you don't have a PLC, but you need to wake up zone 1, you could use a wake up photo eye. Or if there's somebody else's equipment is feeding us, it could provide us with a wake up. I have a load, here it comes.
Mm-hmm.
And on the most upstream zone, zone 1, that signal would wake the card up to accept the load.
Okay, and that's connected to pin 4.
That is correct.
On the control port.
Yes.
That's not like the sensor port. The sensor just detects a load present.
Correct.
Whether it's upstream or downstream.
Correct.
And then the control port, I'm trying not to get these two confused.
Of course, yeah. So the sensor port is the local zone load detection.
Load detection zone. Okay.
Yes. And then the control ports are for interlocking. That way you could use something external to wake up the card, or something external to force accumulation, or to say the lane is full, don't release.
Okay.
So those are, an excellent example is zone 1. You could plug in a wake up sensor. It could be, maybe it's fed by a gravity conveyor, and here comes a load down the gravity. It hits that wake up sensor. The first zone turns on, the load gets to that zone. It pulls the load to the sensor and then on down the conveyor. On the other end, it's the same type of thing. You probably may have some gravity that goes off out into the warehouse or to fill a truck. Mm-hmm. And if that gravity conveyor fills up, you would have a lane full photo eye. And when that photo eye becomes blocked, it would tell the very last zone, the lane is full, stop releasing.
Okay.
And then so that's pin 4. Pin 3 works on any zone, and it will force it. So when you turn it on, any load that arrives will force accumulate. It will not release until you turn off pin 3.
Okay.
If your module is in PLC mode, meaning the PLC is controlling everything, those inputs have no meaning other than whatever the programmer gives them.
Gotcha. You have.
Pin 4 could mean I need to go take a break. Pin 3 could mean we have a mess on aisle 4, something like that.
Correct. They're general inputs at that point.
Correct.
In PLC mode.
Yes.
But ZPA mode, they could mean force accumulation and when we talk in terms of, and I know that the terminology is straightforward, but make it elementary for me.
Sorry. So let me see here. We might have some example of. So local zone accumulation. We're talking about hardwired interlocks. So this means through the control port. And on a control port, if you energize pin 3, that means stop and accumulate any load that arrives. Accumulate because pin 3 is on. When you turn off pin 3, that zone would then release the load.
Okay, when we talk in terms of pin 4 and pin 3, because I remember that control port is a RJ4.
Yes.
So that's where I'm getting confused.
Yeah. Here's your pins. Pins 1 and pin 6, as we discussed, provide 24 volts over and back if the sensor's blocked. Pin 2 ground. Pin 5 voltage. This is pin 4. That's your photo eye signal, or your interlock signal for wake up or lane full. And this one's pin 3. This one means force accumulate.
Okay.
So these pins are these pins here.
Yeah, pin 3 and pin 4. Local accumulate and then interlock digital input.
Yes.
Okay. Force accumulate. Make it elementary for me.
Force accumulate.
Yep.
And then, so this was so we did green flashing red as a module configuration error.
Okay.
I have never seen a customer return a module with this error. The only time I have seen this error is when I set it on purpose to make sure that the indicators work, and that's the only time. I've never seen a customer cause this to happen.
Okay.
But then there's some special cases. Flashing red, all the LEDs. The module is in a stopped state. You would see this, one, if you use the feature in the software called blink and wink. And when you turn wink and blink on, all the LEDs flash red. Its intention is to help you find a module. It works really good for overhead conveyor. Easy Roller PLC says, this module has a problem and you don't know where it is, but you can connect to it with Easy Roll, no problem. And then you turn on blink and wink and you look for the module with all the flashing LEDs. Oh, there it is. And then lastly, this is per side. If, on the left side, all the LEDs are flashing green, and it could be possibly the right at the same time, all the LEDs flashing green.
Okay.
That means someone has used a PLC and turned on maintenance mode. And what that means, the green LED is your indication of maintenance mode. But what that allows maintenance personnel do is to go to that card and replace a motor, replace a sensor, fix O-bands without having to unplug the card. Because if you unplug the card because it only has one power source, you could set faults in the PLC, load distribution, the variable, it'll come and stop. But if you leave on maintenance mode, loads will come from upstream, come down to the maintenance card. They will stop. They will start accumulating. Everything downstream will keep running. So if you had two guys, one guy could hand stack while the other guy is replacing a motor, and you'll have no, very little disruption to throughput.
Okay. Okay. I think I got force accumulate now in my mind. ZPA force accumulate means that if bit, what was it? I think it's bit 3.
Yes.
Bit 4 is for interlocking, right? I think
Yes.
in the control port. So if I force accumulate bit 3, that means that if we're coming in upstream, then we're going to accumulate, meaning we're going to stage.
That is correct.
So I'm just, correct me if I'm wrong. I'm just trying to think this out.
No, you're correct.
Fully understand it, right? I want to take advantage of your time.
Oh,
So
sure.
let's just say I had ERSC 1, 2, and 3.
Okay.
Cards 1, 2, and 3. Okay. And then we set pin 4 on card 3, which was force accumulate. Is
No,
that
you said pin 4. Pin 4 would be lane full.
the last card? That would mean lane full.
Yeah. Pin 3 would force accumulate.
Okay. Okay.
And so the last zone on card 3, you force accumulate that zone. Well, that means that then card 3 can accept one more load for upstream.
That's
It'll
correct.
accumulate. Card 2 could have 2 loads in it. They would accumulate. And card 1 could have 2 loads. So by setting accumulate on the last zone of card 3, you just created a 6-load slug.
Okay. So let's take in terms of card 2.
Okay.
Downstream, I set pin 4 to force accumulate, or
well, now again, you said pin 4, that's interlocking.
Okay.
So if you on node card 2, downstream, if you turn on pin 4 and says lane full, because card 2 is still talking to card 3, and card 3 may say, no, I don't have a load. Card 2 would still release.
He would release into upstream of card 3.
Yes. So because that's interlocking, and because there was a connection, the card overrode the interlock. But if you would have said force accumulate pin 3, that zone would have stopped and not released to card 3.
Ah, gotcha. Okay. So I could have forced accumulate with pin 3 with the middle card
Yes.
2, say downstream zone. If I had a force pin 3, then I would accumulate upstream for card 2, downstream for 1, and upstream for 1.
Yeah. So if loads arrive, they have to accumulate as well.
Okay. Now, if I set pin 4, which is lane full, and if card 3 says, hey, I don't have anything staged in upstream or downstream, you have to release that product to me?
Yes. Because of the connections, because they're 2 and 3 are actually talking.
Right.
So that's why you would use on 2, you would use the accumulate. But on card number 3, for example, there's not a card 4. There's nothing downstream to override the interlock. So if you actually set pin 4, it will accept it because there's no other cards downstream to override that interlock.
Okay, yeah, on card 3.
Yes.
If I set pin 4, which is let me make sure I get these. 3 is force accumulate. 4
Yes.
is
Interlock.
interlock, meaning stop, right? Stop that last zone. What happens to upstream on 3, downstream on 2, upstream on, if I force 1 into an interlock? I mean, card 3 downstream into an interlock.
They will, because the last zone on 3 is accumulated because of the interlock.
Uh-huh.
The other zones, if they have loads, they'll start accumulating back as well.
So they'll stage the product. Okay.
Yes, they will. Yes.
As soon as the sensor becomes blocked for that
They'll
zone.
stop.
Okay.
Yep.
All right. Okay. It's good stuff. I needed to. That's why I needed this training so I could ask all the dumb questions.
Oh no, there's no dumb questions.
Yeah, so I could get an accurate answer as to the functionality. I mean, you can't code it if I don't know exactly how it responds to certain. And
Yes.
when we talk about setting these pins, I can set these programmatically with Rockwell. These are output pins for the controls,
That is
or
correct. So you have two choices.
okay.
So now that you're talking Rockwell, one, you could use outputs from a Rockwell PLC to do hardwire commands to the card, or you could use communications in Ethernet IP and do the exact same thing, but without the hard wires.
Right. So let's just say again that scenario 1, 2, 3. Yes,
Okay.
1, 2, 3, and I want to set the downstream pin for interlock on card 3. Then is there an output? I will use an output word for that particular card. There's a bit in the output word for that card.
Yes, there would be several types of electronic control, meaning communications, that you could do. There's various options.
Okay.
So where hardwire is kind of hardwired and the signal's on or off,
Correct.
with a PLC, there are different ways of accomplishing the same thing.
Gotcha. Okay. All right. It's good stuff. I needed to know ZPA mode and PLC mode. Pin 3 and pin 4. Okay. Very critical. All right.
Right. Connections. These are the actual Phoenix contact part numbers for the power connectors of the cards. If you need to purchase spares, you can buy them through us. I believe sales has a minimum of $50 order, or you can go someplace like DigiKey or someplace like that and purchase them yourself.
Okay. And feel free, Tim. I know it's approaching 10 o'clock, 1 hour. If you need to take a quick break, coffee break.
I usually try to go to about 10:30, and we'll take about 15 minutes.
Okay. Yep.
And then we'll take another one at lunchtime.
That'll be sounds good to me.
Power connections. So if you have one power supply, just bring your power out to your cards. And as we discussed earlier, be sure to tie DC common to ground. When you have more cards, you're going to require more power supplies. Power your modules and make sure your DC commons are tied to the same ground. In this example, it shows an actual wire coming from DC common. Let's say this is a ground one from both of them.
Mm-hmm.
Another option would be not to use this wire, but you could connect these two wires and you would have the same functionality. DC commons are still tied together with one ground reference.
Okay. Okay. You don't have to tie both of them together.
No, just as long as somehow all the DC commons are tied to the same ground. It could be via this way, or it could just be one power supply tied to ground, and then everything else, you just tie all these blue wires together.
Okay. Gotcha.
Again, the grounding, we talked about this earlier. Be sure your motor bracket has a path to ground. You could either, if it doesn't, loosen these two bolts up here, you maybe take them out and scratch off some coating behind this bracket so it's metal on metal, or just loosen one of these up and put a spade connector with a wire that's bonded to ground or DC common, slide it right underneath here, thus providing a path to ground.
Okay.
Power supply sizing. These are things that the integrators should have taken care of. But with this lady know with the ERSC card, although it's one motor, you could select 3 modes of operation. Eco mode will provide 3 amps of starting current for 5 seconds. Boost mode will provide 5 amps of starting current for a second and a half. And Boost 8 will allow up to 8 amps of starting current for 3 seconds. Again, this is usually for like pallet applications. What this will do is, although you can select more current, which will give the motor more torque, unfortunately, more torque means less speed. So just I don't know the exact number, but for an example, eco mode, 100% speed is 100 feet a minute. But you put it into boost mode or boost 8 mode, the motor's going to be stronger, but it's only going to be able to run at 90 feet a minute. So more power means slower speed.
Okay.
And then we're always asked, well, how many motors can we put on a circuit of power? That's a very tricky question because we don't always know how our product will be applied in the field. So we have one standard answer. If you on a 20 amp circuit, if your modules are in ZPA mode, the motor is using eco mode, and the release method is either singulation or gap train, you can have 12 motors on a 20 amp circuit. After that, you're going to have to do the math. Well, I'm going to be drawing 5 amps from this motor on startup. Well, maybe 3 of them is going to start at the same time. Oh, well, that's 15 amps of your 20 amp circuit.
That's correct.
So you just have to think about these things and how it's going to work. All the general tech specs for the module. One I do like to point out, because sometimes people will question this. Input protection rating. It's a class 3 circuit. That means that the circuit on the board is a class 3 self-protecting circuit. That does not mean you have to use a class 3 power supply. If you was to use these, it was a class 2, then we improved it to class 3. But if you was to use, for example, a class 2 power supply, that's limited to 50 watts. That'd barely run one motor. So this is just the actual rating of the circuit itself. That's all that means.
Okay.
And then, of course, you have all the other tech specs, voltages, of course, temperature levels, things like that. Your EMI emissions certifications. The sensor port. So actual input pins, 3 and 4. Although it's one's sensor and one's control port, the schematic is pretty much the same. When the pin's energized, an optocoupler throttles down on the transistor that provides the signal to the card.
Okay.
On the outputs, this is for the control port. I said for simplicity, think of pins 6 and 1 connected to a dry contact. Well, here's the actual circuit. It's an optocoupler that when the sensor becomes blocked, kind of throttles down on this transistor, which would then provide 24 volts back to that card as an output.
Okay.
Motor port information. This right here, talking about motor ports in digital mode and the brake output pin 9. What this is letting us know is if the module for the motor ports in digital mode. If you have an unused motor port and it's in PLC mode, you could turn that port into 4 outputs. The motor windings would become 3 NPN outputs, and the brake pin would be 1 PNP output plus 24 volts. So these are just options.
Okay.
Out of my 17 years here, the only person that I know that has actually done this is me to verify it works. I know of no customers that do this.
I got you.
It's just a feature that's available.
Okay.
Ethernet switch. So it's a standard 3-port switch, 10100 auto detect, full half duplex, and can go up to 100 meters between modules.
Okay. So these are 10100, right?
10100 auto detect.
Okay. So they don't talk giga. I just needed to know that.
Oh, no. These are not gigabits. No.
Okay. These are okay. All right. So they're 10 by default. I don't have to do any configuration to set the speed duplex. So they're ready to go once out of the box.
That's correct. Ready to go right out of the box.
All right. Sounds good.
Supported protocols. Modbus TCP. And that's actually how the modules talk to each other.
Mm-hmm.
Ethernet IP, Rockwell. Profinet IO, Siemens. And CC Link IE Field Basic. That's Mitsubishi.
Okay.
And it requires at least firmware 427 or 507 to have that communications protocol. If you do happen to ever use or have, in my opinion, the misfortune of having to use a Mitsubishi, they're just difficult to program. They're not intuitively understandable.
Correct.
They have 2 kinds of communication, i.e. field basic, which is what we can handle, and they also have IE field. IE field is extremely fast, faster than regular Ethernet. Our switches do not support that.
Okay, gotcha.
Auto configuration. So this is what you would do. You get to a job site, or you as the end user have a new system or an old system you want to rework and clean it up. Excuse me. You would want to perform an auto configuration. When you perform auto configuration, you select a module to be node 1 or the most upstream. So if we select this module.
How do I select that module to be?
Well, that's up to you. Now, here's how you do. So if we want our conveyor to flow this way, right to left, we would go to this module and perform auto configure.
Okay.
But if we wanted our conveyor to go this way, left to right, we would start with this module.
Okay.
So depending on which module we select, that will determine, do we flow this way or do we flow this way?
Gotcha.
Device connections to the modules. This is the most common. 2 motors, 2 sensors.
Okay.
You will also see 1 motor and 1 sensor. And as long as they're both on the same side, that is valid. That is okay. You may also see 1 sensor with 2 motors. If you have this configuration, it does not matter what side the sensor's on.
Okay, hold on. You threw me for a loop there on the second one. Because we went to 2 modules, but module on the second setup, the middle setup, we have 2 modules. Module 1 upstream has a sensor and a motor, but downstream we don't have anything attached to that module.
That is correct, and that is okay. You will see this in the field.
Okay, so
this one is, it's the exact same, except they're both these are both on the right side. These are both on the left side.
So let me ask it. Well, you said there's no dumb questions. Well, let me ask this question. I gotta ask this question, okay? Because if we have this particular setup where we have one sensor, one motor on the, I would say upstream if we're moving left or right, and then we have it on downstream on two different modules, then these modules are considered one. No,
they're still considered two modules and considered to have one zone each. These are just one zone modules.
One zone modules.
Yes.
So this module, okay, let me ask this question. That brings about the next question, okay? So module 1 has a sensor enroller in zone 1 or upstream.
Okay.
In order to transfer to the next module, it's going to look for a confirmation from downstream of that module, not upstream, because it knows that there's no configuration in the upstream. Is that correct?
50-50.
Okay.
No, you're on the exact correct path. What's throwing you off is this part here. And there's a special section that talks about that down here. These two sections talk about that.
Okay.
What these two cards, or actually these four cards, these with just one motor and these with two motors, because there's only one sensor. This card is considered an upstream zone card. This card has no real downstream because it's one zone. So let's say, let's just say, for example, this is the first card in your network, and you would need a wake-up eye. You would plug it into the left control port because we want to wake up the upstream card, the zone. Well, what if this is your very first card? Well, since the side with the sensor is upstream, we plug the wake-up eye into the right control port, and that would wake up this zone.
Okay.
The side with the sensor is always upstream on a single zone card.
Okay. No downstream.
Now, hold on now. The side without the sensor, which would be this side or this side, is the downstream side of the card.
Okay.
Now, just moving along the conveyor, that's not so bad. The cards talk to each other. They know I'm passing from this upstream to this upstream, and the load's going to go down the conveyor.
Okay.
Where it gets confusing, and this caught me on my first job site where I had to go do some, commission a little system. These two cards, all four of these cards have a special case. One, the side with the sensor is always upstream. That means the side without the sensor is always downstream. And this right here, this right here is what got me at the job site.
Correct.
This was the last zone, and I needed to interlock with a lane full sensor. Well, I plugged it into the right side control port. Well, the right side is for interlocking, accumulation. What I was doing was downstream interlocking, lane full. That means that the lane full photo eye had to be plugged into this side of the card. If this side's upstream, this side is downstream. And so on this side, even though pin 4 was on, this card was ignoring it. It kept releasing. But as soon as I plugged the lane full eye into the left side, which is the logical downstream, the lane full interlocking started working correctly. So that's a little tricky, and that's what these two sections right here talk about. So when it comes to single zone cards, meaning only one sensor, the side with the sensor is always upstream. The side without the sensor is always downstream. Still with me, Taylor? Okay, it sounds like we might have had a little internet loss. Let's do this. Can you hear me? I couldn't hear you. No, I can't hear you.